Welcome to the third session. We are still looking at the techniques of integration. If you are using Backhouse, it should be Backhouse 2, Chapter 1. So the techniques of integration, we are now developing into what we call the change of variable. The change of variable, there are two forms. The first form is when you can identify a function and a derivative. The other concept of the function and the derivative had to be emphasized because it's what helps us to determine which variable we are going to change and which substitution we are going to use. So, in cases where there are powers and higher powers, you always try to change the variable of this term inside the big bracket, the bracket with the high power. That term is the one you want to take away. So we can let u equal to this term so that if you differentiate, du is 6x dx and then dx you make a subject, du over 6x. So we are going to substitute 3x plus 2, we replace it with u. We're going to replace x, or we want to replace it, it will find its way, and then we replace dx. So these underlined ones are the ones we are substituting. Should be x into 3x squared plus 2 to the power 4 dx. This should be integral of x times u to the power 4 times du over 6x. This will be very easy. When x cancels, you will have 1 over 6 u to the power 4 du. And the integral of that will be 1 over 6 u to the power 5 over 5 plus a constant. Since u is 3x plus 2, we can write that as 1 over 30 3x squared plus 2 plus a constant. So basically, that's what we are talking about. Exactly. Now, if we have a function such as this sine square 4x cos 4x dx, it should be easy for us to look at the term with a higher power. It should be the one we try to change. It should be the variable we change. So if we let u equal to the sine of 4x, definitely du will be, you differentiate sine to get cos, then you multiply the derivative of the angle. So that should give 4 cos 4x dx. That means that we shall get dx, which is du over 4 cos 4x. So we are going to substitute for sine 4x and dx. We should, this term here becomes integral of sine square 4x cos 4x dx should be integral of u squared times the cosine of 4x times du over 4 times the cosine of 4x. So God knows what happens to the cosine of 4x. So for us, we have a quarter integral of u squared du. It's a quarter u cubed over 3 plus a constant. So since we have u is sine of 4x, so this should be a 12th of sine cubed of 4x plus a constant. So this is how we change variables. Alright, we are trying out more numbers. We are still changing the variable. Sine to the power 5 of x. We shall have to remember from the Pythagorean theorem. That sine square of x is 1 minus cos square of x. These are things we can remember. And therefore, we shall take away one sine, which is here, and we obtain the sine, the remaining even power, sine power 4 of x. We express it in the cosine of x in the form of the cosine. So, since this sine power 4 of x would be sine power 4 of x would be sine squared of x squared. So sine square of x is 1 minus cos square of x. Cos square of x, if you square everything, you get 1 minus 2 cos square x. Cos power 4x, bring it where you had your cos power 4x and open that bracket. It should bring you to something like sine square of x, 2 cos square sine x, sine power 4x, sine x. So this is where exactly the change of variable comes in. The first term is pretty easy. We have that as the cosine of x. Of course, if someone had differentiated the cosine of x, they would have a negative sign. Therefore, we have our negative there. So this one here, we shall have negative 2 integral sine x, and we bring cos x is equal to u times u squared, and then negative du over sine x. So the sine x finds its way. And similarly here, integral u power 4 sine x times negative du over sine x. So sine x all the way finding its way. So you will have your negative cos x plus 2 over 3 u cubed minus, you see the minus is there, then u to the power 5 over 5 plus a constant, and the remaining thing is for you to replace your u. Cos x cubed cos x to the power cos to the power 5 of x plus a constant. So basically, those are the numbers where it's easy for us to identify a function and a derivative. We have only 2 more examples to finish the change of variable. Example number 4. When we cannot find a function and a derivative, think about it. If you differentiate x, you get 1. If you differentiate x, you get 1. So where is the function? Where is the derivative? There's no function, there's no derivative. So in this case, we have more substitutions to make, but they all come from 1. Look at the term with the highest power, x minus 1 to the power 4. So if you let u equal to x minus 1, it means x minus 1 can be removed. Good. Make x the subject, you place that x here, where there's an x, good. And then get the x in terms of du. And then let life roll. So x plus 2 into x minus 1 to the power 4 becomes, where there is x, I put u plus 1. This is u plus 1 plus 2 into u to the power 4 times du. So it's basically u to the power 5 plus 3u to the power 4. That's what we are integrating with respect to u. And this should give u power 6 over 6 plus 3u power 5 over 5. You can take the LCM, u to the power 5. The LCM looks to me like 30, and then I'll remain with 5u, 3 times 5 times 3 times 6 is, what is it, 18, plus 18. So now you substitute back. What was your u? U was x minus 1, so that's nice. So our answer becomes x minus 1 over 30, but that x minus 1 is raised to the power 5. Then 5 into x minus 1 plus 18. So it looks like 1 over 30, x minus 1 to the power 5 into 5x plus 13. So don't forget the constant. Things should look like that. Even when there's no function, there's no derivative, things should look like that. Thank you for being this patient. Now, the last question. Integral of x times the square root of 3x minus 1 dx. If you differentiate x, you don't get 3x. If you differentiate 3x, you don't get x. So there's no function and derivative here. So the only thing we look at is that function in the bracket. We're just struggling to deal with that bracket because it has a square root. Now the square root is going to make life even much harder. So u is equal to the whole square root, or you can take u to equal that function inside the square root. One of those two. So this one is your homework. Try to use this substitution and see whether it can be of use to you. This is something you should try this at home. I encourage you all to try this at home. Now, you can also try what I'm going to do. You can also, there's nothing here we shouldn't try at home. Okay, now, we are going to take u as the square root of 3x minus 1. We shall take a square both sides to have u squared as 3x minus 1. We shall make x the subject. X is that, and then get dx. 2u then over 3. So we shall substitute for dx here. We shall substitute for 3x minus 1 with the square root as u. We shall substitute for this x as u square plus 1. So this should be so fast. U squared plus 1 over 3 integral, that was our x. Then we look for the square root, which is u. Then we get 2u over 3 du. So that means we have 2 over 9. We have 2 over 9 integral u power 4 plus u squared du. That should give 2 over 9 u power 5 over 5 plus u cubed over 3. I'm going to take the LCM. 5 times 3 is 15. 15 times 9, that's 90 plus 40, 135. So this is 2, oh, don't forget your constants. 2 over 135. This is u cubed, is common, u cubed into 3u squared, 3u squared plus 5. Then plus your constant. From then on, I think from then on, we can just substitute back our u. We still have our u. U is the square root of 3x minus 1, which means where we have u squared, we put 3x minus 1. It sounds nice. It sounds nice. So 2 over 135 into 3x minus 1 to the power 3 with the square root times 3 into 3x minus 1 plus 5 plus a constant. So that should give 2 over 135 3x minus 1 to the power 3 over 2 into 9x. It looks like that, I don't know. I encourage you to try all these things at home. When you watch these videos, please give us feedback, comment on the YouTube channel. I don't know whether you should subscribe. You will find out whether you need to subscribe. It's up to you. It's up to you. What I know is that I'm doing my work to make sure that you learn these things from the comfort of your house. May God bless you. May God bless you. May God bless you so much.